In this lesson we will be dividing when we have radicals under this radical. When we have variables under the radical. When I do this problem, we did one like this before, I think, where we can say, I'm going to put the whole square root under here. We did this with numbers. And then I have y to the 10th over y to the 1st. So then I can use my division rules with exponents. Bigger y, top or bottom, it's on the top. 10 minus 1 is 9. So I can simplify that right away to the square root of y to the 9th. Then I try to break that down. I know I would have 9 halves that I try to divide out. 9 halves is 4 and 1 half. So it divides evenly 4 times, which gives me y to the 4th. My remainder is y, the square root of y. That's where my 1 half goes. So my answer is y to the 4th root y. And again, if you need work on breaking down stuff like that, we'll do some of that tomorrow. Number 14 then, this whole big square root can be written as y to the 8th over y to the 4th. So I say bigger y, top or bottom? Top. 8 minus 4 is 4. So I have the square root of y to the 4th. And when I divide that by 2, I'd get y squared. I did not start with an even and with an odd, so that's my answer. Number 15, I now have some coefficients in front of these variables, so same idea. I'm going to say 30x to the 5th over 6x squared. So I reduce the fraction of 36 and get 5. And bigger x, top or bottom? Top, 5 minus 2 is 3. So I have the square root of x to the 3rd. When I try to separate these, I'd say I have the square root of 5 times the square root of x cubed. Square root of 5, the only factors are 1 and 5, so that's not going to break down. So I'm going to leave that alone. Square root of x cubed, I think, is going to break down. I'd have 3 halves, which is 1 and a half. So I'd have x to the 1st, and then the square root of x to the 1st. So here's where my 1 and 1 half comes from. So my answer, this would be simplest form. I write my numbers or variables outside the radical first, so I'd have this x. And then I'd have the square root of 5x. Now, some of you might be thinking that we did start with an even index, this 2, and end with an odd exponent. But if there's still a variable under the radical, you don't need the absolute value, because if that was negative, it would make it unsolvable anyways. So it's only when you don't have a variable under the radical that you need to use those absolute value signs. And we will follow up with this a little bit tomorrow too.